The next one we're on is question 4, okay? So what we have here is the ball bouncing question, okay? So what happens is it has a height of 2. And each time the ball hits, it bounces back up at 3/4, right? So 2 multiplied by 3/4, which ends up to be 3/2. So 3/2. Then the next one, answer multiplied by 3/2, which is 9/4. Now, 3/4 of the height of the previous bounce, okay? So, 1 sec, 3/4. So it's 3/2 multiplied by 3/4. Let's make sure I don't make some easy errors earlier on. 9/8. So we keep multiplying by 9/8, and then we get our 27/32, and our 81/128. Now we have an R value of 3/4. Okay. Now, which is no bother. Okay. So find in meters the total vertical distance up and down the ball had traveled when it hit the ground for the 5th time. Give your answer in fraction form. So the 5th time. Okay. Well, what we can say here is that it's going to be 2. First, second, third, 4th bounce, 5th bounce. Okay. And what we're saying is that that's 2, 3/2, 3/2, 3/4, 3/4. Oh, sorry, not 3/4, 9/8, excuse me. 3/2, 3/2, 9/8, 9/8, 27/32, 27/32, 81/128, 81/128. Now, what is to drag all these down? Okay, that's what we're looking at here. So we're going to add all them together. Plus, 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 plus. And what we get there is 635/64, which is the same as 10 and 13/64. Now we could have rewrote this as 2 plus 2 times 3/2, which is 3/2 plus 9/8 plus 27/32 plus 81/128. This here is a geometric sequence. Okay, where this is T1, and that'd be T2, T3, T4, and T5 as above. But we can rewrite this. We don't have to make that T1, so what we could say instead is that, look, your T1, your T2, your T3, and your T4. We could do it that way. Now, what's the next question asks us? Probably the sum to infinity, if I'm honest. Continue the ball of S infinity, find the meters of total vertical distance, right? So S infinity, it'd be the first bounce plus 2 times, remember I had it a second ago, 3/2 plus 9/8 plus 27/32 plus, I forget what the other one is, 81/128 plus dot dot dot. Okay, so if we call that one T1, T2, T3, and T4, we have an A value of 3/2 and an R value of 3/4. S infinity, that is in total distance, or so. Because S infinity means it's going to be bouncing up and down, up and down, up and down, up and down, and then it's going to just fizzle out forever. Okay, so we're going to figure out what height, how much it bounces when these diminish in heights. Okay, so S infinity equals 3 over 2 divided by 1 minus 3 quarters. Okay, now that's going to equal is we'll find out now. 3, yeah. And then we'll change this to 3 over 2. 1 minus 3 quarters. 4. 6. Interesting. That's 6. So that's 2 plus 2 times 6, which means 14 meters in total. Okay, so question 4 was quite easy. Question 5. Let W be a complex number such Wn is equal to 1. W is not equal to 1. S equals 1 plus W squared plus Wn minus 1. Use the formula of the sum of geometric sequence to write the value of S in its simplest form. That's fair enough. So, Sn, or S affinity, so equals A into 1 minus R. A equals 1. R value equals omega. Now, it doesn't say infinite, it says finite, so I have to change this. It's not infinite. Just looking for Sn equals A into 1 minus Rn all over 1 minus R. So A is 1. That's 1 minus W to the power of n all over 1 minus W. However, W to the power of n equals 1. So that's 1 bracket 1 minus 1 all over 1 minus W. It's just 1 times 0 over 1 minus W equals 0. 0 over any number is 0. So that's question 5 done. Not as difficult as I was originally expecting. Okay. This one here. Show that as an arithmetic sequence, right? So remember the rule of logs. Let's say log 10 squared equals 2 log 10. You're allowed to bring the power to the front. Same way log 5 cubed is equal to 3 log 5. So what we're going to do here is we're going to use that rule to figure out what T1 is. Right? So T1 equals ln A. T2 equals ln A squared, which is 2 ln A. T3 equals ln A cubed, which is 3 ln A. We have ln A plus 2 ln A plus 3 ln A. So A equals ln A, starting point. To prove it's an arithmetic sequence, okay, and D will also equal ln A. Difference. Okay, but to prove it's an arithmetic sequence, now we may have to do Tn minus 1. So T3 minus T2 equals T2 minus T1. So 3 ln A minus 2 ln A equals 2A minus ln A. So ln A equals ln A. Series is arithmetic. Okay. Prove that the sequence is Prove that the sequence is arithmetic and find the common difference. Okay, so that just shows that that just shows that the first three is arithmetic. It doesn't show that everything's arithmetic. So we have to do Tn minus Tn minus 1 will equal D. In the same way, T3 minus T2 equals D. D is ln A, which is awesome. So Tn equals ln A to the power of n. Tn minus 1 equals ln A n to the minus 1, which equals n ln A, which equals n minus 1 ln A, which equals n ln A minus ln A. So that D equals Tn minus 1. So it's n ln A minus bracket n ln A minus ln A. And then the answer here is just simply going to be ln A. And this proves it's arithmetic. For all n element n. Okay, what do we got next? Find the value of A for which T1 plus T2 plus T3 plus all of this equals 10,100. This basically is S100, okay, which is 10,110. I'm going to find Sn of an arithmetic sequence is n over 2 into A plus n minus 1 times D. A equals ln A, D equals ln A. N equals 100. So S100, which in turn equals 10,100, equals 100 over 2 ln A plus 99 times ln A, which equals 50 times 100 ln A over 10,100. Alright, now what we're going to get is 5,000 ln A equals 10,100. 100 divided by 5,000 equals 2.02. So ln A equals 2.02. Now, what value of A does this? Pause. So I got ln A plus 100 ln A, 50 ln A, 10,100 divided by 5,000, 2.02, no matter. So log base EA equals 2.02, A equals e to the power of 2.02, A equals e to the power of 2.02, e to the power of 2.02, syntax error, a numpty there, and we get 7.54. Yeah, that differs from the answer in the market scheme. I believe the market scheme made an error. Okay. or 7.538 if you wanted to 3 decimal places. We must see what it was asking for. Didn't actually ask for specific decimal places. Okay, next part on. Verify for all values of a that t1 plus t2 plus t3 plus t10 plus 100d equals t11 to t20. So this is not the worst one in the world, alright? So what we have is, if I ask you guys for S10, it will be t1 plus t2 plus t3 plus dot 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 t10. If I ask you for S20, it'd be t1 plus t2 plus dot 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 t20. Okay? Now, therefore, t11, so if I was to just take away this part, it'd be t10, then it'd be t11, t12 plus dot 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 t20. Okay, so this part here is basically S20 minus S11. Okay, and this part here is S10. So Sn is n over 2 into a plus n minus 1 times d. A is still ln a, d is still ln a. Okay, so Sn equals n over 2 into ln a plus n minus 1 times ln a. Now let's figure out what S10 is. So 10 will equal, so that's 5 times ln a. That's 10 there. That will be equal to 9 plus 9 ln a. So that means the S10 is going to be 50 ln a. Here we go in reverse. Figure out what S20 is going to be. It's 20. So we're going to have 20. Then we're going to have 20 minus 1, which is 19. So we're going to have 10 ln a plus 19 ln a, which is 200 ln a. Now, what we can do next is we can have S10. This here is S10, and S10 is 50 ln a. 50 ln a plus 100d. 100d is 100 ln a equals S20 minus S10. S20 minus S10 is 150 ln a. And we've therefore proven that 150 ln a equals 150 ln a. Undusted.